Welcome to another episode on how to build your own supercomputer. And in this episode, I'm going to show you how to reflash a node when you're using the NVMe drive, because that is a little bit different. I'm Garrett, and this is TimmerTech. Now, let's get started on today's video. So if you have been using an NVMe drive with one of your Turing PI nodes and you reflashed it, then you might have noticed some odd behavior. And that is that when you reflashed your node, it still keeps booting from your NVMe drive with your old installation or your broken installation. Because, hey, you had a reason for reflashing. Now, actually, this is correct behavior, and that has to do with the boot order. So for the Turing RK1 modules, the boot order is NVMe first, so it will always try to boot from the NVMe. Now, in order to make sure that you boot from the storage chip where the new OS has been reflashed, you need to interrupt that boot order and tell the Turing PI to boot from its internal storage chip. That way, then you can reformat the NVMe drive, or you can reinstall the OS from the chip back onto the NVMe, like I've shown in my previous video. But it is correct. When you reflash your image to a Turing RK1 module, then it will keep booting from the NVMe even while you don't want to, or while you're not expecting to. So I'm going to show you how to handle that situation and get started on a brand new NVMe drive install. Let's dive in. So first, I'm going to walk you through the steps of what we will be doing. What we're going to be doing is we're going to interrupt the boot process and set it to boot from the internal storage chips where we reflashed our new OS. Now, here's the thing. We need 2 terminals for that, and up here is a video with more detail on how to access that and all the details behind it. In this video, I'm quickly gonna go through it and get started on what we will be doing today, and not particular in depth on the uart. So watch that video before so you can continue with this tutorial. Now, what we're gonna do is we're gonna interrupt the boot process. We only have like 5 seconds, and we're gonna tell it to boot from the internal storage chip. And then we're gonna verify that we have booted from the internal storage chips, and then you can make your modifications to the NVMe drive for in case that you have a broken install or you want to wipe the drive. As I said before, we need 2 terminals, one where we're going to show the output and the boot process of the node that we're going to fix, and 2, the terminal where we're going to control the power up of that node. So let's switch over to our first terminal. What we're going to be doing, so right now, by the way, that node I was talking about, that node is running. That's not a problem. And the reason for that is I'm going to actually show you with a little trick that we can actually like double verify. So the first thing I'm going to do is I'm going to log into my node 1 by using SSH and the IP number of that node, 110.21. And we're in that node. Now, what I'm going to be doing is first we're going to check. Now, it's a very simple thing to check where the root partition is. And we can do that with the mount table. So we can do cat/etc/mtab. And then I'm going to grab, single quote, space/space quote. And this will isolate the root partition. And as you can see, bam, there it is. We're running on the NVMe. Now what I'm going to do is I'm going to use sudo, and I'm going to use the command touch to create a file. I'm going to create a file in the root, and I'm call it let's say I'm going to call it TimmerTech. ls/root. Here we have our created file, and this is to show that, hey, if we reflash it and we're still on the NVMe. Now if I switch the boot order and I'm on the storage chip, we should see in the mount table that we are actually running the root partition of the storage chip. Now, I used in a previous video the official Ubuntu Rockchip install to copy over the OS to the NVMe drive. That means that on the storage chip is still a untouched Ubuntu install. The only thing that has been changed in that Ubuntu install is the initial login where you set your new password. But overall, you can actually consider that to be your backup OS in case everything is broken. What I'm gonna do is I'm gonna log out of this node because we verified, and I'm gonna clear this. Now I'm gonna log into the BMC. Root at turingpi.local. Turing. Now what I'm gonna do is I'm gonna start a uart session to node 1 to see all the logging of that node, like the console logging. And we do that with picocom to /dev ttys1 because for Turing Pi 2.5 it's 1, 2, 3, 4. Everything is correctly numbered. For Turing Pi 2.4 these numbers do not correlate to a node slot. Please watch my video I mentioned before. You can check the links down below how to access with picocom the nodes of a Turing Pi 2.4 version. And we're gonna set the baud rate, which basically means the speed, and that is 115/200. Now we're ready. Now we're gonna switch over to our second terminal, and that should be this one. Yay, and there it is. And what we're gonna do is we're gonna prepare this node for shutdown. So what I'm gonna do is I'm gonna log into that node again, and I'm gonna say 168.10.21. I'm gonna log into node 1 and I'm gonna shut it down. Sudo shutdown, and I'm gonna hold it. I'm just gonna shut it down like you turn off your computer. Shutdown -h now. Enter, and when we jump over to our first terminal, we suddenly see already that there is some logging here which show, hey, node is powered down. Jumping back to our other terminal, I'm now gonna give the command to completely power down the node. TPI power min and 1 off. Poof, node is off. Now we can check this. TPI power status, all nodes are off. Now here's what I'm gonna do. I'm gonna power on this node, but before I hit enter, I am actually gonna jump my screen to the first terminal so that you can see the logging immediately. So when you're doing this, you have to have two terminals, press enter to boot up the node, and immediately switch to your first terminal because you need to hit a key within certain 5 seconds window to hold the boot process. So I'm gonna now, in this terminal, I am gonna clear the screen. What I'm gonna do is TPI power node 1 on. I'm not gonna press enter yet. And now I'm switching over to the first terminal. And as you can see, we're still waiting. Now, I'm gonna hit enter in my second terminal, and I'm keeping my first terminal focused so you guys can see. And at some point you will see 5, 4, 3, you will see a countdown. That's what we need to interrupt. That's the boot process. And that is where we can tell the Turing Pi to boot from its internal storage. So I'm gonna press enter, and we're back. And now it's booting up, and there it is. Ooh, I had 2 seconds to spare. And at some point you will see this, hit any key to stop auto boot. That is the one that you want to interrupt. And then you see this little miniature prompt. This is the boot prompt. And here we can tell the Turing Pi not to boot from the NVMe, but from its internal storage. Now, how do we do that? We're gonna use a command called setn for set environment. And it is boot_targets mmc0. Now, what does that mean? That means that we are telling the boot to boot from from the MMC. That's the name of the internal storage chip, and not from the NVMe drive. And then, as you can see, nothing happens. That's correct, because now we're going to tell the bootloader to boot up. And we do that simply by the command boot. And it found 2 Ubuntu, 1 Ubuntu, and a rescue. And as you can see, it's booting up. And there it is. The entire node is booted up. And as you can see, you get a prompt. Now we can log in here, but we're going to use our normal SSH login. So we're going to jump to the other terminal and we're going to say SSH Ubuntu at that IP number of node 1. Enter. Well, it did find it. So we're logging in and we are now logged in. Now let's clear this screen. Now what we're going to do is we can actually check quickly, well, is the file that we placed on the NVMe drive, is that still there? So we're going to see ls/, we're going to see a list. Hey, awesome, the file is not there. You know what? Let's check to make sure that we are running on the internal storage chip. So what we're going to do again is we're going to do cat/etc mtop from mount table pipe grab quote space/space quote, and that is grab the line that has space/space. That's the root partition, because in the mount table are a lot of slashes and we want specifically this line. And there you see it, MMC BLK block 0 P2 partition 2. We are now back on the storage chip. And now you are in the original flashed OS. You can do a reflash of your NVMe drive with the Ubuntu Rock chip install, or actually wipe your entire NVMe drive. So in this video, I just showed you how you can change the boot order of a Turing PI node, how to go back to its internal storage chip in case you do not want to boot it from NVMe drive and you want to fix that, or you want to wipe the NVMe drive, reinstall the NVMe drive, and this is how you do it. Now, if you enjoyed this video, comment below, like and subscribe. It really helps me out, and I see you guys in the next video. I'm Garrett, and this is TimmerTech.